Welcome to the Deep Dive. Today, we're getting into something pretty crucial for, well, any operation that wants to run smoothly. Maintenance metrics.
That's right.
We know you're probably looking for the real story, the stuff that actually matters, without getting bogged down.
Yeah.
So we've tried to boil it down, distill the key info you need to really get a handle on how well a facility is ticking.
Exactly. Think of this as your, let's say, quick guide to maintenance KPIs, key performance indicators.
APIs, right?
Our mission here is basically to pull out the essential knowledge about these metrics and, crucially, why they matter to anyone who cares about efficiency and, well, avoiding extensive problems.
Yeah, those nasty surprises.
We've dug into an insightful article to give you sort of the concentrated version of what you need to know.
Okay, let's unpack that. Why should we really care about these maintenance KPIs? Sounds a bit technical, maybe, like something for the maintenance folks only.
Well, fundamentally, running good maintenance, it really comes down to making smart decisions, and those decisions need data. Good data. These KPIs, they're like the vital signs for your facility's operational health.
Vital signs, I like that.
Yeah. By watching them, you get a real, tangible way to measure how effective your maintenance actually is.
So it's not just about did something break, but more like how good are we at stopping things from breaking?
Precisely. It's about finding those specific areas you can improve. And that improvement, it leads directly to lower costs, equipment that runs more reliably, and just better efficiency all around.
Makes sense. You can't really fix what you don't measure.
You got it. You really can't optimize if you don't track and understand what's happening.
So what are the big ones then? The key things to track? This article calls out 10 essential KPIs. Let's start with planned maintenance percentage, PMP.
Right, PMP, planned maintenance percentage. This one tells you, essentially, what proportion of your maintenance time is spent on planned proactive work versus, reactive stuff, fixing things after they break.
Okay, planned versus reactive. How do you figure that out?
The calculation is pretty straightforward. It's your planned maintenance hours divided by the total maintenance hours, then times 100 to get a percentage.
So total maintenance is the whole pie.
Exactly. And PMP tells you how big that proactive planned slice is. You want a bigger slice, ideally.
Right. More planning, less panic. Why is having that bigger proactive slice so important, though?
Well, a high PMP, it's a really strong signal. It says your maintenance program is mature, it's effective, it shows the team is actually prioritizing those routine checks, the upkeep tasks, the things that stop big failures later.
Oh, okay.
And being proactive like that, it gives you much better control over resources. You can schedule things more predictably. And the big one, it really cuts down on those unexpected, usually expensive breakdowns.
Fewer surprise breakdowns.
Yeah.
Everyone wants that. So what does tracking this PMP trend tell us over time?
If you see your PMP going up consistently, that's great. It shows you're moving away from just fighting fires, reacting all the time, towards a more strategic, planned way of doing maintenance.
A positive shift.
Definitely. And the article points out something like a CMMS, that's a computerized maintenance management system, is super helpful here.
The software.
Yeah, it helps you track this accurately over time and use that data to actually make better decisions about your maintenance strategy going forward. For those listening who use CMMS, you know how vital good data input is for this KPI to mean anything.
Absolutely. Garbage in, garbage out. Okay, next one. Mean time to repair, MTTR. That sounds like how fast we fix stuff.
That's exactly it. MTTR. It's the average time it takes to get a piece of equipment back up and running after it fails.
Okay.
The formula is just the total time spent on repairs divided by the number of repairs you did in that period.
So lower is better here, right? Faster repairs.
Generally, yes. A lower MTTR suggests your team is responsive, efficient. It minimizes that downtime, which, costs money.
Definitely. Less downtime is always good. But are there nuances? Like, what does a high versus low MTTR really tell us? Could a low MTTR ever be misleading?
That's a great point. So, yes, consistently low MTTR, usually good means an efficient team. But if it's low on the same piece of equipment over and over, it could mean you're quick at patching things up, but maybe not fixing the root cause, So the problem keeps coming back.
Quick fixes instead of real solutions.
Potentially. On the flip side, a high MTTR, that can signal a few things, maybe training gaps, maybe delays getting spare parts, or maybe the equipment itself is just really complex or old, making repairs take longer.
So context matters. Like if you see high MTTR on one specific machine.
Exactly. Say it's always high for a certain type of pump, even if you have parts ready, that might point towards needing some specialized training for your techs on that specific pump model.
That makes a lot of sense. Okay, now the flip side, not how fast we fix, but how long things run before they break. Mean time between failures, MTBF.
That's precisely MTBF. This measures the average time a piece of equipment operates successfully between failures.
How's that calculated?
It's the total operational time divided by the number of failures during that time. This one's really fundamental for gauging how reliable your assets actually are.
And here, higher is better, obviously. Longer time between breakdowns.
Absolutely. A high MTBF is a good sign that your maintenance strategies, especially the preventive stuff linked back to that high PMP we talked about,
Right.
that those strategies are working. They're minimizing those unplanned stops. Plus, tracking MTBF gives you data to sort of predict future service needs, maybe help decide when it's time to replace or upgrade equipment.
So it's not just about fixing quick, but making sure fixes are less needed.
Exactly right. And the article stresses that looking at MTBF together with MTTR gives you a much fuller picture.
How so?
Well, like we said, a high MTBF is good. But say you have a high MTBF, but when things do fail, the MTTR is also really high. That might mean the failures are rare but catastrophic or complex when they happen.
Okay.
Or if MTBF is low, even with a decent PMP, maybe your preventative tasks aren't the right ones or not effective enough. It pushes you to look deeper.
Got it. Okay, moving on. Maintenance backlog. This sounds like a pile of unfinished work. Is that bad?
Think of it as, the queue of maintenance jobs, tasks that are scheduled or identified but not done yet. Now, having some backlog is normal. Things change, priorities shift.
Sure.
But a backlog that's constantly huge or always growing, that can be a big red flag.
What kind of trouble are we talking about?
It could mean you don't have enough resources, maybe not enough people, or maybe not the right skills on the team.
Or maybe bad planning.
Or bad planning, exactly. Inefficient scheduling. The real danger is that important preventative maintenance gets pushed back. And when that happens, your risk of equipment failure goes up, and often your long-term costs do too.
So keeping that to-do list manageable is pretty key for avoiding future pain.
Absolutely. If you monitor the backlog carefully, you can spot problems early, rebalance workloads, make sure urgent stuff gets done, find those bottlenecks in your process.
And the software helps here too, I assume.
Definitely. The article mentions that a CMMS gives you that real-time view you need to actually manage and shrink the backlog effectively. Helps keep things moving, improves schedule compliance.
Okay, next is overall equipment effectiveness, OEE. This sounds like a big picture metric.
It really is. OEE is quite comprehensive. It looks at three things together. Availability, is the equipment ready when you need it? Performance, is it running as fast as it should? And quality, is it making good product, not scrap?
Availability, performance, quality.
Okay. Yep. You multiply the percentages for those three, and that gives you your OEE score. It's a holistic look at how well you're using that equipment.
So a high OEE means machines are up, running fast, and making good stuff.
Pretty much, yeah. It's a strong sign of a well-run operation, and it reflects well on the maintenance side, too. Tracking OEE helps you pinpoint where you're losing productivity.
How?
Well, is your availability low? Maybe frequent breakdowns are the issue. Is performance lagging? Maybe the machine isn't running at its design speed. Quality problems? Maybe defects are high, which could be maintenance-related.
That seems incredibly useful for digging into hidden problems.
It really is. The article highlights that OEE, especially when you look at it alongside other KPIs, is a powerful driver for continuous improvement. Helps you tackle those unexpected failures that kill your availability score.
And I guess modern software makes tracking this easier.
Oh, significantly. Collecting the data for availability, performance, quality, visualizing trends, making decisions based on that data to boost reliability maintenance software is key there.
Right. Okay, let's shift to making sure plans actually happen. Preventative maintenance compliance.
Yes, PM compliance. This one measures how well your team actually completes the preventive maintenance tasks that were scheduled.
So did we do what we said we were going to do?
Essentially, yes. The calculation is number of PM tasks completed, number of PM tasks planned, 100. It's a direct check on how well you're implementing your proactive strategy.
So if we plan 10 PMs, do 7, that's 70% compliance.
Exactly, and you want that number high. High PM compliance means the team is diligently doing those proactive tasks that are designed to prevent failures, reduce reactive work.
What might cause low compliance if the team isn't getting the planned work done?
Could be several things. Maybe the schedule was unrealistic to begin with, not enough staff to cover it, problems getting spare parts when needed, or maybe even lack of training on how to do certain PM tasks properly.
And low compliance leads to.
Likely more unexpected downtime, higher costs in the long run. The article notes that specialized PM software can really help automate scheduling, send reminders, track compliance, so you can see if there's a problem and figure out why.
Okay, let's talk money. Maintenance cost per unit of production. How does this tie into efficiency?
This KPI gives you a very direct look at cost effectiveness. It calculates your total maintenance spend for every unit your facility produces.
Linking costs directly to output.
Exactly. It gives you a real tangible feel for the financial efficiency of your maintenance approach.
So if that cost per unit starts creeping up, alarm bells?
Pretty much, yeah. An increase could mean several things. Maybe your processes are getting inefficient. Maybe you're having more frequent breakdowns that need expensive repairs.
Or maybe too much emergency work.
Or too much costly emergency work instead of cheaper preventive work.
Yes. How does tracking this help manage the budget better?
Well, if you watch this KPI closely, it gives you solid insights for budgeting, for deciding where to put resources, maybe even for making investment decisions like, is it time to upgrade this machine?
Right.
It helps you see the ROI on your maintenance spending. And again, maintenance management software often helps track this, letting you pinpoint where you might save money.
Okay, another one. Total maintenance hours spent. Seems simple, just counting hours. What's the deeper insight?
It is fairly straightforward, just the total labor hours for all maintenance, planned and unplanned. But it tells you a lot about workload and productivity.
How so?
It helps you see how your team's time is actually being spent. Is it mostly on planned work, or is a huge chunk going to emergencies? Is the workload reasonable?
And if emergencies are eating up a lot of hours?
That's a strong hint your preventive maintenance isn't cutting it. Looking at this helps you reallocate people better, maybe identify training needs, or just plan schedules more effectively down the road.
And tying this into a CMMS helps keep track accurately.
For sure. Accurate tracking, better forecasting of labor, it all connects.
Nearly there. Number 9, schedule compliance. How's this different from PM compliance?
Good question. Schedule compliance is broader. It looks at the percentage of all scheduled maintenance tasks, so preventative and reactive repairs that were planned that get completed on time.
All scheduled work, not just the preventive stuff.
Exactly. It's a direct measure of how reliable your whole maintenance planning and execution process is.
So even if we plan well, if we keep missing the deadlines we set, our schedule compliance drops.
Precisely. And low schedule compliance. That can cause a domino effect. Delays lead to more delays. The backlog grows.
And things might break because maintenance got pushed back.
Right. The risk goes up. High schedule compliance, on the other hand, shows your team is sticking to the plan, keeping PMs on track, minimizing that potential for unexpected downtime.
And software helps keep this on track too.
As the article notes, yeah. Monitoring adherence, finding out why things are delayed, improving planning software is a big help there.
Okay, last one on the main list. Equipment availability. This sounds pretty fundamental. Is the machine ready to go?
It really is fundamental. Availability is the percentage of time equipment is ready and able to do its job during the hours it's supposed to be running.
It's a direct reflection of maintenance effectiveness.
Absolutely. Maximizing availability is, in many ways, the ultimate goal of maintenance.
Makes sense.
High availability means your maintenance team is doing a great job preventing failures and keeping any downtime short when repairs are needed.
What influences it?
It's directly impacted by, well, your PM program effectiveness, how fast you respond to failures, that's your MTTR again, and how well you manage spare parts.
And better availability means?
More production, happier customers. It's a direct link. And the article rightly emphasizes using a CMMS to track availability trends and make sure maintenance work aligns with production goals.
Wow, okay. That's a really solid overview of those 10 KPIs. It's interesting how they each give a slightly different angle on the same goal, a smooth, efficient operation. The article you used also touched on some related ideas in its FAQs, kind of connecting the dots back to these main KPIs, right?
Yes, exactly. It's good to see how these fit into the bigger picture. Like they mentioned emergency maintenance percentage.
Which wasn't in the main 10.
Right, but it's basically just the flip side of planned maintenance percentage. If your emergency percentage is high, it's a clear warning you're probably too reactive, maybe not as efficient as you could be.
And equipment downtime, we hit that from a few angles with MTTR, MTBF, availability.
We did, and the FAQs likely just reinforced how those KPIs all feed into understanding and controlling downtime, which is obviously critical for production and planning.
What about energy consumption? That wasn't a core maintenance KPI either.
No, but it's an interesting related point. Sometimes, if a machine suddenly starts using way more energy,
Something's wrong.
it could signal an underlying mechanical issue, maybe increased friction, misalignment, something maintenance might need to look at. So, tracking energy can sometimes be an early warning sign for asset health. And good for sustainability, too, of course.
Makes sense. And the maintenance backlog, we covered that one.
Yep, one of the essential 10. The FAQs probably just hammered home like keeping an eye on it is crucial for managing workload and preventing failures from deferred maintenance.
Maintenance labor hours.
Also one of the 10. The FAQs likely just added emphasis on using it to check productivity, see if people are stretched too thin, and optimize how tasks are assigned.
Okay, and the last connection mentioned was asset utilization. How does that fit in?
Asset utilization is about how much you're actually using your equipment compared to how much you could be using it.
So if it's sitting idle a lot,
Right. And why is it idle? Low utilization could absolutely be because of too much downtime caused by maintenance issues or maybe poor scheduling. So looking at utilization alongside things like availability helps you spot those bottlenecks and make sure you're getting the most out of your expensive assets.
got it. So pulling it all together then,
Mhm.
keeping tabs on these maintenance KPIs, understanding them,
Yeah.
it really gives you the insights you need for efficiency, reliability, controlling costs.
Pretty much. It lets you make improvements based on actual data, avoid those nasty operational surprises.
It helps you move from just reacting to problems.
Exactly. To being proactive, strategic about maintenance, which leads to a much healthier, more efficient, more predictable operation overall.
This has been a really useful deep dive. Okay, so for you listening, here's something to think about. In your world, your area of interest or responsibility, which one or two of these KPIs jumps out at you? Which ones do you think might give you the quickest, most useful insights right now?
Yeah, and what simple steps could you maybe take just to start tracking or understanding one of them a bit better in your own context?
Maybe even just reflect on, what potential headaches, those unexpected failures or slowdowns could you possibly avoid if you had a clearer picture from these numbers? Something to chew on. Thanks for joining us on the Deep Dive.